Alright, in this lesson we're going to talk about a couple of things. Primarily we're going to be looking at what I call function family, and we're going to be looking at what I call the parent function, which is basically a function in which other functions are made out of by modifying them. So let's go ahead and start out with something that I know you're going to be familiar with. Our very first function is going to be linear. Now, that's our function family. There's many different linear equations you've been dealing with, are what we call linear functions. And a good example one, I'm just going to make some random stuff up so that you can see some examples. If we're talking about a linear function, for example, we might use f of x is equal to 3x plus 2. Right, so this is a common function that you've seen in Algebra 1 and even 8th grade math. And I'm going to go ahead and go to our calculator right quick, and I'm going to type it in. Now, instead of using f of x, I'm going to go ahead and put a y in there, because remember, y and f of x are synonymous with one another. Actually, I'll just write a note right here. This is the same thing as saying y equals 3x plus 2. This top one is written as a function. The bottom one is written as an equation. But it's the same thing. Right? Just a different way of notating it, because when we write it as a function, this f of x is the name of the function. So I'm going to go ahead and put in y equals 3x plus 2. Alright? And you can see this is a linear, and the word line is in linear, so it creates a line. And when we talk about the parent function, so in other words, what function did it actually come from before it was modified in any way? Well, the parent function for this would be what we call f of x is simply equal to x. This is the parent function. So it was a really simple function, and we'll type that one in as well. And when I say f of x, once again, it could be represented as y equals x. And if I were to put that into here, I'm going to go ahead and graph it, y equals x. And you're going to see this green line is the original function. Now, we modified this function, so it's of the same family. It's still a linear function, but notice that the slope on the original parent function is 1, because there's that invisible 1 in front of the x. And we changed that slope to a 3. And then we also added a y-intercept of 2. Whereas this parent function, it's actually 0, right? It's x plus 0. Now we don't write the plus 0 because we leave zeros off because it doesn't really change much. However, just know that this is x plus 0. If there's nothing there, it's represented by 0, and that's because its y-intercept is right here at origin, and it goes through 0.00. Notice that the family function, right, where it's modified, it has a y-intercept of 2, and therefore if I were to go up to where it crosses the y-axis, right here, you will notice that it tells me that that point is 0, 2. So, why this is of the same family, it originated from this parent function of f of x equals x. Now I'm going to draw a small picture here. I recommend if you got some paper, it would probably be a good idea to jot down these notes just to have you some examples as you're going through your lesson for Algebra 2 and looking at these different types of functions. So what I'm going to do is I'm going to draw the parent function. It is linear. So let's look at our next one, right? So this is our first one. I'm going to put a 1 right there. And let's go to another one. So the next one we're going to talk about is we're going to talk about what I would like to call quadratic, because that's another one that you just dealt with in Algebra 1. And so I'm going to write the word quadratic. And when I say quadratic, this is what I mean. I'm going to write an example. Let's go ahead and say f of x is equal to x squared plus 2. So this is a quadratic function here, right? That's the function family it belongs to, is quadratics. Now, on the other hand, it had a parent function that it originally started with. And the parent function for this one would have been f of x is equal to simply x squared. That is the parent function. So let's take a look at the difference between the two. I'm going to erase these two linear that we had, and let's go ahead and throw in a quadratic real quick. First, I'm going to do the parent function. So we can look at it first, x squared. So I have x and to the power of 2. So you can see here it makes a nice parabola. Notice that its vertex is at origin, 0, 0. And then we have this other quadratic, right, that's been modified. Notice we added 2 to it. And so we're going to see a shift. We're going to see a shift in the parabola. There's going to be some movement. So I'm going to put that new one in. So let's say x squared plus 2. And notice that the parabola shifted up 2 units, right? So the vertex went from being at origin to being right up here at 0, 2. So I'm going to go ahead and I'm going to draw a graph real quick of that. And if I were you, I would draw you a picture of this real quick just so you have an example. Because you're going to have to name some functions in just a little bit, say what family they're from. Alright, and now we're going to move to our next one. So we got quadratic done, we got linear done, and now we're going to move to another one you're familiar with, which is exponential. So number 3 is going to be exponential. That would be the function family. Now if I were to draw an example of that or write it out, we could say something like f of x is equal to 5 times 2 to the power of x. So this is an example of exponential. Now, if we go back and we want to go back to the basic value, right, it would be the parent function on that would be f of x is equal to a b to the power of x. So this is our parent function, right? We have some value for a, some value for b to the power of x. And this one I just gave an example. So let's go ahead and we'll look at a real basic one and then we'll compare it to something like this that's been modified quite a bit. So if I go over here and I'm going to type in 5, actually, let me change that real quick. Let's put y equals 5. We'll put a parenthesis. We have a b value, which is a growth factor of 2. And then I'm going to put to the power of x. Let's see. Okay, so now you can see this right here. You can see that we have a curve here. So let's go ahead and draw an image of a basic graph that we just graphed. So I'm going to come over here and what I want you to do is and we're just making sketches here, so you're just going to draw a curve. And that's what an exponential function looks like. It can curve up or it can curve down and over. So anything that looks like that, that's going to be exponential. So let's go ahead and go to our next function. So I'm going to move this up a little bit. We're going to do our fourth one. And now we're going to get into some new ones. Some new ones that you didn't see in Algebra 1, but you're going to be seeing here in Algebra 2. So let's go ahead and do what I call a cubic. They're of the cubic family. And an example of a cubic function would be, for instance, we could do f of x is equal to, and let's say 0.5x cubed. When we say cubed, remember that means the power of 3. When you were doing geometry, right, 8th grade math, or if you're doing geometry in high school, either way, you would have went ahead and found surface area that was squared, and then you found what we call volume, and volume was cubed. It always had a power of 3. And then I'm going to go ahead and let's subtract a number from here. Let's say minus 5. Let's stick with all 5s here. And if we were to write a parent function for this, the parent function would look very simple. It would just simply be f of x is equal to x cubed. So we'll go ahead and compare those two real quick. I'm going to go ahead and erase this other one. Let me type it in. So for this one, we simply have y is equal to 0.5, and then we have x, and I'm going to go ahead and put to the third power, and minus 5. So you can see how this looks, right? I call this the broken arrow. That's the way it was taught to me in college. We always say it looks kind of like a broken arrow. And so I'm going to just draw an image of that real quick. And I do want to go ahead and just show you one. If we were to just use x cubed to see what it looks like. So if I do x, and then I change that up there to the third power. And you can see that it's still the broken arrow, right? But now it goes through origin. So I'm going to come down, curve, and over. And once again, this is part of the cubic family. Its parent function is f of x equals x cubed. So let's go ahead and go to our next one. So the fifth one that we're going to talk about is going to be a rational function. So when I say rational, I hope you're thinking fractions, because you should be thinking fractions. So the family it belongs to is called rational. And to give you an example of a rational function, we might have something like f of x is equal to 6 over x. Now, when we talk about the parent function, the parent equation, right, it's going to be f of x is equal to 1 over x. I'm going to prepare me a graph because we're going to draw a picture of it as well. So let's go ahead and graph these real quick and just give you a visual of what they look like. And for instance, on this one right here, I'm going to put y equals, and I'm going to do 6 over x. And you can see right here, right, we have these two curves. And if I were to do the parent function, 1 over x, then I could go ahead and say y equals 1 divided by x. And notice they just get a little closer to origin. They pull in a little bit. So let's go ahead and draw those real quick. Alright, the sixth function that we're going to look at is we're going to look at what is known as the function family of square roots. And it has a parent function as well. But let's go ahead and start by writing the name of the function family. And it's going to be square root. To give you an example of one of those, we could say something like f of x is equal to 3 square root of x minus 1. Now, when it comes to the parent function, our parent function for something like this would end up being f of x is equal to the square root of x. And once again, we're going to draw an image just so you have an idea of what it looks like, and we're going to graph it real quick. So I'm going to throw this one in there. So I have 3, actually let me rephrase that, y equals 3, and then I'm going to go ahead and put my square root symbol, and I'm going to put in x minus 1. Alright, so you can see what this looks like, right? We have this curve right here. And if I were to put the regular parent function, I would just go ahead and say y equals the square root of x. And so I'm just going to draw an image of one. It doesn't matter which one you draw an image of as long as you have an example so you know what it looks like. And now we're going to move on to our next one. So let's go ahead and write number 7. So our seventh one, we're going to go ahead and look at absolute value. So I'm going to write absolute value. That's the name of the function family. And that's going to look something like f of x is equal to x plus 2. Now, if we're talking about a parent function for an absolute value would simply be f of x is equal to the absolute value of x. Once again, I'm going to draw an image. so you can match up the picture. And let me erase these. Let's go ahead and put that in. So we got y is equal to the absolute value of x, and then we'll put plus 2. So you can see here, right, it looks like a v, and notice that it is shifted up. Now if we just go back and we do the parent function, so if I do y equals x, notice it shifts back down and it starts at origin. So I'm going to write that original one, and it looks like a v coming out, and that is a absolute value function. So we only have 2 left, and the next one we're going to look at is a cube root. So the function family is going to be cube root. And to give you an example of that one, we might have something like f of x is equal to 2, and I'm going to put a cubed root. Notice my index for my radical is a 3, and then we might have something like x plus 2. Now, if I were to write the parent function for this, it would look like this. F of x is simply equal to a cube root of x. And again, when I say cube root, I'm talking about the index, which is normally 2. Instead of a 2 up here, we have a 3 for the index. And so let's graph these and see what they look like. So if I graph the original equals, for this one, I'm going to have to go ahead and click the functions button. I'm going to pull this down until we find a cube root. And notice right there it has a little n up there. It's going to let us change that number to a cube. Otherwise, it would assume that it's an index of 2. And then I'm going to go ahead and type in my x plus 2. And it's almost like a sideways broken arrow. So you got that curve right there. Now, if I did the original, right, the parent function, let's go ahead and put that in. So we would end up with y is equal to, go down here, put my cube root in there, and put an x. So there we go. Notice it goes through origin. So I'm going to draw an image of it real quick. It looks like this. And the last one that we're going to talk about this year is logarithmic. So let me go ahead and write number 9. And we're going to write this belongs to a function family of logarithmic. Notice I have f of x equals log 2x. And we have our parent function, which is f of x equals log bx. And I went ahead and drew a graph of roughly how it should look. So let me throw it in here and show you how you could put it in Desmos so you could take a look at it. And you can simply do y equals, hit function, drag it down to log, and once you click on it, you can change your values. I'm actually going to throw a 2 in here, and I'm going to put an x in the parentheses, and notice how this looks right here. So it looks very similar to what I drew over here on my graph, and again, this is just a rough sketch. That way when you see the image, you have an idea of what type of graph you're dealing with. So now you have all the different types that you'll be dealing with in Algebra 2, and you can complete your assignment. So go ahead and use these notes so that you can name the functions on the sheet that your teacher gave you.